In this video, we're going to take a look at examples of UML diagrams and the information that they present. Object-oriented software is based on objects. So objects ultimately live in computer memory. Computer memory is just a long array of memory locations, and basically this space in memory is occupied by objects. So the object may be occupying certain space in memory. This rather primitive representation of objects, of course, is not very convenient and may be used during program debugging, but in no way that it would specify or visualize or document the fact that objects have logical meaning, they can have relationship, and they can visualize object-oriented concepts meaningful to both the users of the application and the developers. So unified modeling language allows us to construct different views or model the system, and that falls into two basic categories: the static view of the system, which is sort of like a structure that will eventually be placed in computer memory, and also dynamic view in terms of a user interaction with the system, behavior or of the state or modifications to the state internally in a specific object, activity, which is just a visualization of processes, and sequence diagram, which also shows interaction of objects at runtime. Some of the diagrams can be used by both humans and also tools that, for example, if you populate class diagram with every single detail of your class attributes and methods or functions that this class contains, you can actually generate a prototype class in software. Picking your favorite programming language, you can generate out of these boxes, you can generate the actual definitions of classes in form of software source files. But perhaps the biggest value of UML, that it allows everyone involved to use the same methodology in understanding the concepts that the software is trying to implement. The class diagram allows us to describe the structure of our objects and how they're going to be occupying computer memory. So there's actually direct correspondence between the class diagram and the actual structures that will be placed in computer memory. At the same time, class diagram uses only blueprints, the prototypes of the objects that will exist in memory. They're called classes. So we're going to be looking at quite a few of these class diagrams today. But the object diagram, on the other hand, allows us to provide a direct look at specific instances of objects. So it's quite simple. Basically, you're going to draw a box and provide the name of the class, and you can also add to this box some data attributes, something that the class, the instance of the class may contain in computer memory. And you can draw another box just like this, and you can also specify that this object has pointer or reference to this instance. So therefore, when this object is in memory and it's doing something, executing some sort of task, it may be able to invoke behaviors or methods of another object because it has access to it. So this is the idea behind the object diagram. So you provide sort of like a name of the object at the top of every object and say that this is a car driver and this is a gearbox, and we have interaction between the car driver and part of the interface of the car. So this is just an idea behind the object diagram. So I'm not going to spend too much time with object diagrams. Rather, I would like to continue our conversation about class diagrams. Here's an example of a class diagram right here. So the idea is that we have a bank, which is an object in memory. We have a bank account, and of course when we define these classes, we can have multiple instances of these objects in memory, because once you have a definition of a class, this class definition can be used to create multiple objects of this type. Bank account, which will have the number of an account, some kind of owner identifier, the balance, and these are the methods or operations available on this. So there is a relationship between classes that, of course, the class diagrams allow us to specify, and also the multiplicity. So here we say that the bank can have from 0 to n number of bank accounts. So there are two kinds of bank accounts: the savings account and the checking account, and they implement or extend rather the idea of the bank account. And the bank account is an incomplete concept because it says that the withdrawal operation is an abstract operation, which means that this operation has not been fully defined yet at this level of the bank account. So when we provide concrete implementation of a savings account, we will be providing this operation, a concrete version of this operation. And then when we establish the savings account, and when a bank is trying to use the bank account, it will call withdraw, and the operation will be directed to this implementation because it was a savings account. On the other hand, if it was a checking account, then another implementation of withdraw operation will be used. So you can see that it's quite useful to have these diagrams, because we have the whole story of what is possible and what kind of structure we need to support our software system. And of course we also have a customer which can have 0 or 1 savings and checking accounts. So these multiplicity specifiers allow us to provide more or less concrete specification of the possibilities of existence of accounts for a specific customer. So this is quite good. We call these things constraints. So any kind of constraint is helpful in understanding how exactly our software abstraction is supposed to work. And you see that the customer has an ID, the savings account, the checking account, which are these references that would be referring to an instance of this object or this object in memory. And here the customer will have addresses of them at runtime, and so the customer object can start invoking these operations and using these values that represent the state of every object. So with this respect, I should also mention that the class diagram like this one does not provide an immediate information about the actual object creation. These dynamic diagrams or behavioral diagrams, such as for instance sequence diagram, will be able to visualize when these objects are created. To begin with, this is just a blueprint. This is not exactly any kind of dynamic view. This is just a static view of the structure that we're planning to have to be able to support the business rules of our problem domain. In this case, a banking